ठीक है ना यहाँ तक? So on the left hand side we take a delta connected balanced source, on the right hand side I take a delta connected balanced load. Now if you apply your KVL to this thing, you just apply your KVL to this side, then you see, let's take, it is, I think just one thing is missing, a dash, okay, it is VB, okay, I think this should be, if you take just, sorry, this diagram is something wrong because it is C and it is B, because we have to take correct diagram. Okay, let's wait. So it is B to B now, that's why we are getting voltage wrong. So it is C to C, it is C to C. Now it is C to C, just wait. So it is IC, that is equals to IL, and here it is IL equals to IB. Okay, now if you apply the KVL in this loop, because in star connection we see that the line current is equals to the phase current, but this is your phase voltage BP, okay, and this is also your line voltage A to B is line voltage, and this is your phase voltage. So if you apply this thing, so if you apply, then VAB is minus VL is equals to 0, then your VAB is equals to VL, and I can write BP is equals to VL. Now the first point about a delta connection is what? For the delta connection, phase voltage is equals to the line voltage. So this is our first point about the delta connection, and the second point we will see the current equation. So we will apply the KCL at A. So for the line current, we will apply the KCL at A. So KCL at A. Now if you apply the KCL at A, then minus A plus IAB minus of, it is minus of IAC equals to 0. From that I can write IA, the line current, is equals to IAB minus IAC. This is the first line current. Similarly, I take KCL at B point. KCL at B point. Okay. So if you apply the KCL at B point, minus of IB, then it is minus of IAB. This is minus, okay, plus IBC equals to 0. From that I can write IB equals to IBC minus IB. Okay, so this is your second line current. Okay, because we have to take the line current expression to prove your result. Similarly, I just take KCL at C point. KCL at C point. Now minus of IC, plus of ICA, and minus of IBC is equals to 0. From that I can write IC equals to ICA minus IBC. Okay, I think यहाँ तक clear होगी बात. Now, so if you take IAB is what? IAB is what? This is BAB upon mod Z angle plus phi. And what is VAB? VAB is this voltage. So it is BP angle 0 degree divided by mod Z phi. ठीक है यहाँ तक. So if you see this, it is IP angle minus phi, and that can also be written as IM sin omega t minus phi. Okay. Similarly, if you see IBC, where is IBC? This is IBC. So IBC is what? BC. It is BBC upon mod Z angle phi. So similarly, it is can write as BBC, and BBC is what voltage? This voltage. BBC is this voltage. So it is what? BBC. So BBC is what? BP angle minus 120 degree divided by mod Z एंगल प्लस फाइव। ठीक है यहाँ तक। सो अगर हम आगे देखें तो इसको लिख सकते हैं आई एम साइन ओमेगा टी माइनस 120 डिग्री माइनस फाइव। ठीक है। तो सिमिलरली आई जस्ट राइट आई सी ए दैट इज इक्वल टू, आई directly put im sin omega t plus 120 minus 5. ठीक है। So these are the current for the phase values. Now if you take phi 0 if it is resistive load, then it is very easy. Now take resistive load. If ZL is R, then you see there your current are like that. These currents are I sin Im, it is Im sin omega t minus sin omega t. Similarly, it is Im sin omega t minus 120 degree, and this current becomes Im sin omega t plus 120 degree, because for the resistive load, the phi is 0. I'm taking the resistive load for the simplicity of the calculation. Otherwise, the calculation is little bit tough. Okay, but results are same. Okay, so these are the things we have to take in. Now I just erase this diagram so that we can prove our result. Okay, so for the delta connection, line voltage is equals to the phase voltages, and we have to drive our current relation. So I just made all these things clear. Now हम देखते हैं हमारे लाइन करंट्स की इक्वेशंस क्या हैं. So अगर हम फर्स्ट लाइन करंट को एक बार हम जस्ट इस बार एक ही करंट को ड्राइव करेंगे जिससे कि सिमिलर रिजल्ट आ जाए. सो फर्स्ट लाइन करंट इज आई ए इक्वल्स टू आई एल. ठीक है, आई ए इज इक्वल्स टू आई एल. नाउ व्हाट इज आई ए बी? इफ यू सी आई ए बी इज व्हाट आई पी एंगल 0 डिग्री. इफ यू रिमेंबर अभी हमने लिखा, देन इट इज आई ए सी ना. आई ए सी इज व्हाट आई पी एंगल plus 120 degree. ठीक है यहाँ तक. So if you solve this IP common, then it is cos 0 plus j sin 0 minus cos 120 degree minus j sin 120 degree. So when you solve this IA or IL, this is root 3 times of IP, and angle is, I just take angle is minus 30 degree. Okay. So this is the first result. Now similarly, if you take the second expression, same as first, then your IB is IL is equals to root 3 IP angle minus 120 degree. Similarly, you take IC is equals to IL, the third expression, then you will get root 3 IP angle plus 120 degree. ठीक है यहाँ तक. So these are the result for the delta connection. Now from the result we can take next point. For the delta connection, line current is root 3 times of phase current. ठीक है यहाँ तक. So the delta connection is used for increase the current. So for large current, for the large transformer, you can use your delta connection. Okay, where you are demanding more current, then you can use your delta connection. Now see the phasor diagram of delta connection. Okay, so just take first phase current. Here the phase current 1, and this is your phase current 2, and this is phase current 2. Now it is your IAB. First it is IAB, that is what IP angle 0 degree. Similarly IAB, that is BC, and it is IBC, that is equals to angle minus 120 degree. Okay. Similarly this current is your ICA, that is equals to IP angle plus 120 degree. If you see your last result, then now if we extend in the negative direction, then it is what? Minus IBC. It is what? Minus IAB. And this is what? It is minus of ICA. यहाँ तक clear है? Now see the result. The first line current is IAB minus IAC. IAB minus IAC. So ये रही आपकी पहली line current जो कि ये रही. ठीक है यहाँ तक? So this is your first line current IA. √3 IP angle minus 30 degree. So this angle now, this angle is 30 degree. ठीक है यहाँ तक ना. Similarly अगर हम second current की बात करें तो IB is what? IBC, BC positive minus AB. This is your third line current. Sorry, second line current. IB is equals to √3 IP minus 120 degree. Okay. ठीक है यहाँ तक ना. Next अगर हम देखें minus 120. Okay, let's see the result. Yeah, minus 120. Similarly, if you take the third current, there is CA positive and BC minus. So this is your third line current. Okay. So it is IC is equals to √3 IP angle plus 120 degree. ठीक है यहाँ तक. So check करते हैं हमने result. Now, okay. So now the conclusion from the delta connection we can make. If the phase sequence of phase current is ABC, then the phase sequence of line current is also same. ठीक है. नेक्स्ट चेक कर सकते हैं हम डायग्राम से. सिमिलरली अगर मैं नेक्स्ट कंक्लूजन की बात करूं, इफ phase currents are balanced, then line current are also balanced. Okay, so these are some points about the delta connection, and just we proved that line current is √3 times of phase current. So for the delta connection, if we conclude, for the delta connection, the line voltage and the phase voltage are same, and line current is equals to the √3 times of the phase voltage. And the last point, I think we missed that, that is I'm writing here, I just forget that thing. For the delta connection, the line current is lagging phase current by 30 degree. For delta connection, line current lags phase current by 30 degree. So in the case of star connection, the voltage are leading by 30 degree, but in case of delta connection, line currents are lagging to 30 degree. So this is about the delta connection, and now we will compare the star and delta connection. After that we will take some numerical. So this is about your delta connection. I hope so ये सारी चीजें समझ में आई होंगी. This is a little bit complex, but it is, if you take concept wise, then it is easy. So start करते हैं हमने comparison of star versus delta. So start करते हैं अपना comparison between the star and delta. So on the left hand side we take star, and on the right hand side we take delta connection. Okay. So first point about the star and delta is what? If we connect similar ends of coil, it forms star connection. So we have already seen the result, star connection. ठीक है. So it is A, B, C, A dash, B dash and C dash. So if you just connect these things, you're a star connection. Now in that the delta connection, if we connect delta connection, we connect dissimilar ends, then it forms delta connection. ठीक है यहाँ तक? So if you want to take example, then let's take 3 coil A, B, C, A dash, B dash, and C dash. Okay. So if you connect dissimilar and either start to finish or finish to start, you will get your delta connection. And the delta is the closed connection. Start to finish, and then start to finish. So this is about your delta connection theory. Okay. So this is the first point about the star versus delta. Now, second point. In star connection, line voltage is root 3 times of phase voltage. ठीक है यहाँ तक? So यहाँ पे देखते हैं, अगर एग्जाम्पल की बात करें तो आपको याद होना चाहिए VL is equals to √3 BP. ठीक है. Now in the delta connection, similar points अगर हम बात करें, in delta connection, line voltage is equal to phase voltage. That is what? BL is equals to VP. Now from this, if you see, VP is equals to VL upon √3. Okay, so it is 57.7% of VL, but it is VP is 100% of VL. Clear? Now your insulation is designed on the basis of per phase voltage. So in case of star connection, the insulation is 57% of the line voltage, or we can say the insulation required is 57% or 58%. But in case of delta connection, you require 100%. Okay, so we can say in case of star connection, you require less insulation. So we can take advantage of this insulation level, and the star connection is used for increasing or for the large voltage rating. So if you see, used for high voltage system. Similarly, it is used for, it is third point. Okay. So this system used for LV system. ठीक है यहाँ तक? Now in the next point, I just take fourth point. In star connection, line current H equals to the phase current. In star connection, line current is equals to the phase current. So in that point, in delta connection, line current H equals to the √3 times of phase current. Okay. Now here, if you take more current, then size of the wire is more, because current is directly proportional to area. So if you use star connection for higher current rating, then the size is giant or large. But here, if you see, IP is equals to IL upon √3. So 57.7% of IL. So अगर यहाँ पर एरिया है या वॉल्यूम जो है कॉपर वायर का 57% लगेगा, then it is here, it is 100%. So that's why in the next point, I take this point, star connection is used for low current application. current application. ठीक है यहाँ तक. Similarly, if you take fifth point for this point, used for high current application. Clear है यहाँ तक? So these are the fifth comparison point with respect to what? Star versus delta. Now we will take sixth point here for the star versus delta. So here we take star and here we will take the delta connection. Now see that sixth point. In the sixth point, in star connection, line voltage leads phase voltage by 30 degree. 30 degree is important and word lead is important. Okay. Similarly, in the sixth point, in delta connection, line current lags phase current by 30 degree. So important thing is what? Here the word is 30 degree lead and here the word lags of 30 degree. Now if you draw the diagram of these two, that means this is your phase voltage, it is your VAN, then it is your VL, 30 degree phase shift. ठीक है, this is your line voltage, that is √3 BP angle plus 30 degree. ठीक है यहाँ तक. Now if you draw for the phase delta connection, then your line current is, your phase current is this I angle 0 degree, then your line current is, but please it is more, it is large because line voltage are more. Okay. Similarly, the phase current is this, then it is minus 30 and your line current is equals to √3 times of IP minus of 30 degree. So this is the meaning of this thing. Okay. So it is used for high voltage and it is used for low voltage, low current, high. So the main application, the sixth point, sorry, in the seventh point, if you see, seventh point, application, star connection is used for high voltage, low current. Now in case of delta connection application, अगर हम बात करें, that is seventh point, and application is what? Now application is what? Low voltage and high current application. So these are the seventh point about the star connection. So next we will see the next point. I think line voltage, line current, angle and application we covered, and let's see the next point. Okay, so 9.2, it is having low insulation because insulation is 57, so high insulation. It is for, sorry, it is 8th point now, 8th point. So per phase insulation is low, but here the per phase insulation is high. Insulation is high. ठीक है यहाँ तक. So these are the some points. Next, और अभी हम पॉइंट देखते हैं. ये तो सिर्फ 7 ही 8 लगभग 8 पॉइंट हुए, और भी इन लोगों में डिफरेंस है, वो देखते हैं क्या होते हैं. उसके बाद हम अपने न्यूमेरिकल स्टार्ट करेंगे. सो अब हम देखते हैं अपने नेक्स्ट पॉइंट ऑफ कंपैरिजन बिटवीन स्टार वर्सेस डेल्टा. सो वी हैव डिस्कस्ड 8 पॉइंट अबाउट द स्टार एंड डेल्टा कनेक्शन. तो अगले अगर हम पॉइंट देखें, इट इज 9th पॉइंट. नाउ हियर आल्सो अ 9th पॉइंट विद रिस्पेक्ट टू स्टार एंड डेल्टा कनेक्शन. अब अगर हम बात करें, सो अगर आपने देखा हो resistance in just wait, resistance in delta is equals to 3 times of star. Okay, wait. So similarly, inductor in delta is what? 3 times of L star, but the C in delta is 1/3 times of C star. Okay. Similarly, G in delta is 1/3 times of G star. Okay, but So R delta, R star is equals to R delta upon 3, L star equals to L delta upon 3, okay, and we will have what thing, C star is equals to 3 times of C delta, and G star is equals to 3 times of G delta. So अगर हम यहाँ पे नोट करने की वाली बात देखें तो ये क्या होगा, these are the same thing and these are the two different things now. So this is the reason that in when you take capture bank in delta connection, when you take capture bank in delta connection, the size of the capture bank is reduced by 1/3 as compared to the star connection. That's why in three-phase power factor improvement, the capture bank are in terms of delta. Okay. Now 10th point अगर हम देखें इसके रिस्पेक्टिव में, so अगर 10th point की बात की जाए तो P यहाँ से स्टार्ट करते हैं 10, P delta is equals to 3 times of P star, but P star is equals to P delta. That is the most important question. Okay. Next अगर हम पार्ट देखें 11th point अगर की बात करें, now star connection is used in distribution system, in secondary distribution system, secondary distribution system. Okay, star connection is used in secondary distribution system because it gives neutral point. It gives neutral point. Okay, but the delta connection cannot be used. Delta connection cannot be used in secondary distribution system. Since it cannot have neutral point. ठीक है यहाँ तक. अब अगर हम बात करें जो हमारा सेकेंडरी डिस्ट्रीब्यूशन सिस्टम का ट्रांसफार्मर है तो उसके कनेक्शन देखें कैसे होते हैं. उसके कनेक्शन जो होते हैं, दिस इज योर ट्रांसफार्मर 3 phase incoming, it is 11 kV and it is giving you, and it is R by B in neutral. Okay, so this is delta. In primary side is delta, but at the secondary side it is a star neutral. So in secondary distribution system, the primary side of the transformer is delta, but the secondary side is star with neutral. Okay, so these are the points which we have covered in your star and delta connection, and this point is covered by a numerical. For this point, that and the power in delta is 3 times of power in star, that we will cover by a numerical. So up to here the difference is over, star versus delta, and next we will see the numerical